Good morning, everyone, and in this lecture, I will be instructing you how to perform enlarging and reducing the formula. So, when we say a formula, it is a recipe or a list of ingredients with specific amounts to make a final product. So, in pharmacy, there will be certain situations in which you are required to compound or prepare special dosage forms for a specific patient. Or sometimes you require a smaller or larger amount than what the recipe is available. So in pharmacy, RX actually means recipe and it is equivalent to our formula. So when do we perform adjustment of the formula? Most of the time, we will be employing this when the amount we need to prepare is not exactly what is in our recipe. So take for example our first example. This here on the screen is the recipe for chocolate cake. So this is good for 16 servings. And what you are asked is to prepare for a 10 serving cake. So how will we go about this one? So this is a simple extension of ratio and proportion in which all of these ingredients are in a ratio to the final amount, which is 16 servings. So that is to 16. Okay, so 450 grams is to 16 servings. 650 grams is to 16 servings. Okay, you can do it like that for 50 grams is to 16 servings. Then you don't know how many do you need, how many grams, if you only need 10 servings. So you can do it in a ratio and proportion way in which you will get the ratio for each ingredient for the list and get the specific amounts. So let's try this one out for 50 grams over 16 servings. We don't know how many grams we need for 10 servings. 10 servings for 50 grams. 16 servings equals X grams. That is 281.25 grams for a 10 serving cake. Okay, you can do this procedure for every ingredient on the list. However, it will take you a long computation. What we want to do is to simplify it so we can solve faster. So this is a valid method and you will use ratio and proportion for every ingredient. However, there is another way. Okay, in getting the other way, we have our factor. You need to get your factor. To get the factor, the formula is what is desired over what is available. Usually what is available is in the recipe. So our factor is what do we desire? We desire 10 servings. And what is available in our recipe is 16 servings. Okay? Please take note that the desired and available should always be the same unit. So they can cancel each other out. So our factor here would be 10 divided by 16. That would be 0.625. It's a unitless number. It's a unitless value. So once you have your factor, simply multiply everything by the factor. So let's try it on the first one. We should get around 281 for 50 times 0.625. That is the same value. So we got the same value for the first one. So we are actually doing the same computation. We just did it in a simpler manner in which you will be computing for everything else. You do not need to add the values in the final solution only to declare that in the adjusted recipe you only need this amounts of ingredient. Okay, 650 times 0.625, 406.25. Okay, since this is a unitless value, the final unit or the value you will get will always follow what you multiplied with the factor. So grams, 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 grams. Okay, I will not be solving them all since this is only a demonstration on how to do it. So that is how you go about adjusting our recipe. Okay, it does not matter if it is in ml or if it is in grams. It will always apply the same factor. Okay, however, in this case, 4 large eggs, 4 times 0.625, you have 2.5 eggs. Okay, it depends if you're going to use 3 or 2, or you can actually divide the eggs by 2. It's in this circumstance, I don't know what is the rule of thumb for baking, but I think it's 2 eggs. Okay, so you won't always get a perfect whole number since you are simply adjusting the recipe. So this is useful in cooking or in times where you're going to adjust several recipes, like in baking, or later on our demonstration would be on alcohol. Okay, so that's how you perform adjusting the formula. Okay, so take this one. So this is the recipe for zinc oxide ointment. What you need to look at in this recipe is that there is nothing on the last line. The last line is white ointment. So this recipe means that to make zinc oxide ointment, you need to combine 200 grams of zinc oxide, 150 grams of mineral oil, and 650 grams of our white ointment. This is a grand total of our 1000 grams. So if I ask you to prepare only 250 grams, so we have our desired over our recipe, and that is 0.25. We only need to multiply all values by 0.25. So this is 50, 37.5, and 162.5. Very simple, but it only applies to this type of formula. Later on, you will encounter another type of formula like this one. So you will usually encounter this type of formula when you're going to prepare a liquid or semi-solid dosage form or any multi-phase system. So this is the recipe for calamine lotion. So you're going to combine 80 grams of calamine, 80 grams of zinc oxide, 20 ml of glycerin, 250 ml of bentonite magma, and please take note of the last line. So the last line is calcium hydroxide topical solution, QS add 1000 ml. You're supposed to look closely at things that contain QS add. QS add in Latin is to make or to make. Okay, what this means is you are going to add everything above this line. You're going to combine everything, and after combining, you're going to add sufficient. It's not to make, it's add sufficient amount. Fiat is to make. But it could also be read in English as to make 1000 ml. Yes, it actually is. It carries the same meaning. So that's why I was confused on to make. Or add a sufficient amount to make 1000 ml. So what you're going to do is to combine all the ingredients and put it in a graduating cylinder or any graduated vessel and add sufficient amounts of calcium hydroxide topical solution to make 1000 ml. This is not measured. Okay, take for example, you have your beaker here and this is your ingredients and this is 1000 ml. If these are all your ingredients, you're going to add calcium hydroxide until it reaches 1000 ml. Okay, it's not measured. You just eyeball it to make 1000 ml. And the key thing here is 1000 ml is the final volume. This is the final volume of our recipe. So this recipe is good for 1000 ml. Okay, so to summarize, whenever you see QS add, it means that this is not measured and the final volume is 1000 ml. Okay, so if I ask you to make 100 ml of calamine lotion, the factor would be 100 ml and the recipe is for 1000 ml. So our factor is 0.1. We simply multiply everything by 0.1. The final line, which has the QS add, is not multiplied by 0.1. Okay, so this is 8, 2, and 25. So if we're going to rewrite the new recipe, calamine, 8 grams, zinc oxide, 8 grams, glycerin, 2 ml, bentonite magma, 25 ml, and calcium hydroxide topical solution, QS add, 100 ml. You're not going to multiply the final value by the factor. Instead, you're going to simply rewrite the final value or the final ingredient as your desired amount. Although if you multiply them, you will get the same amount. So that is for recipes that contain QS add. Next, this type of recipe does not contain any particular measurements. So this is the recipe for frozen daiquiri. So as you can see, it contains ingredients and it contains their certain amounts. However, this is in parts. When we say parts, this is similar to a ratio. Okay. This is also a ratio to the final amount. And this has no specific value yet. So if you're asked to make 250 ml of frozen daiquiri, and you have this recipe right here, the first thing you need to do is to simply add all the parts. Okay, so 3 plus 1.5 plus 1 part is 5.5 parts. Once you have the total amount of parts, divide the part of the ingredient, 3.5 parts, over 5.5 parts. Since this is also a ratio, 3 is to 5.5, 1.5 is to 1, and 1 is to 5.5. 1.5 over 5.5, 1 part over 5.5. Okay, so these are all in parts, they will cancel out, and simply multiply by the final amount. So the final amount is 250 ml. Since these are all parts, they will cancel out. And what you will have is 3 divided by 5.5, 0.545. I did not multiply by 250. 136.36 ml. 68.18 ml and syrup is 45.45 ml. Okay, if you add them all together, you would get 249.99. Okay, so 250 ml, 250 ml. So in recipes that require parts, our procedure is to add all the parts, divide the ingredient parts by the total parts, then multiply with the final desired amount, and you will get the desired amount for each ingredient. Okay, so these are some sample problems. Please solve them on your own. A separate video would be posted for our sample problem solutions. Thank you, and that would be all for our adjusting the formula.